So 7.3, we're talking all about logarithms, and logarithms are something new, but they're also something awesome. Part of what makes these so awesome is their connection to exponents, and that's really what I want you to be thinking about, is how are they related? Because ultimately I want you to be able to explain why log base 0 of 3 and log base 1 of 3 do not exist. Log base 0 of 3, log base 1 of 3 do not exist. And then it's important that you reference the way in which these logarithms relate to exponents in your explanation. Okay? So, let's take a look first of all at what log actually means, because in order to answer this, you're going to have to know that. First, let's think of a hypothetical question. How many times would you have to double 1 to get to 8? Well, you would go, okay, 1 doubled is 2. 2 doubled is 4. 4 doubled is 8. You would double 1 3 times to get to 8. Not so difficult. How many times would you have to double 1 to get to 1024? That's where this gets difficult, right? We can think of it as an exponential equation. Think about that formula. AT equals the amount after some amount of time equals the initial amount, and then our rate raised to the t power. Essentially, what we need to solve is we need to solve 1024 equals 1 times 2 raised to the t power. That's going to be difficult. The way we could look at that equation is 2x, 2 raised to the x equals 1024. That's a challenging question to solve. I mean, we could pick and pray and just kind of guess and check and try, but that's going to take us a really long time. And so a better way to do it is to be able to have a way to undo exponents, right? We need to undo this operation of having x in the exponent. So what we use is called a logarithm. A logarithm is the exponent to which a base is raised to give a desired value. The base here is 2. The logarithm, the exponent is x, and we want to know what x is when the answer is 1024. As a result, logarithmic equations, because they have the idea of a base and an exponent and things like that, they're really closely related to exponential equations, and the relationship is shown like this, with this little picture. An exponential equation is written as b raised to the x equals a. 2 raised to the x equals 1024. A logarithmic equation takes those numbers and rearranges them so that we can solve it. A logarithmic equation takes that base and puts it down below here. It takes whatever our answer was, and that's what goes here. And then the exponent is the logarithm. It's what we're solving for. So log base b of a equals x. If we were looking at this problem, 2 to the x equals 1024, it would be log base 2 of 1024 equals x. See how now x will be by itself? We're solving for what the value of the exponent is. That's what makes it so cool. Okay. Let's practice a little bit with this changing from exponential to logarithmic, because that's really what you have to have down in order to be successful this lesson, and actually for the rest of the chapter too. So let's take a look at how that works. The first one is done for us, right? We have a base of 4. The exponent or logarithm is 0, and then the value that we're trying to get is 1. We read this as log base 4 of 1 is 0. Is meaning equals. But that's how the numbers all fit. Log base 4 of 1, I'll try to make these colors match for you, is 0. Now, so let's look at how do we change the next one. Well, the base, that 3, that's going to be the base in our power. So I'm going to put a 3 as my base. exponent is what it equals. So I'm going to say 3 to the 4th. And then I'm going to say equals that 81. That's the value. Really quickly, pause me, and I want you to try to get these last 3 in this chart filled out. So you try the last 3 real quick. Push pause and make it happen. Okay, how'd you do? Okay. How'd it go? Let's look at the next one. The base is -5. The exponent, which carries over and becomes what the logarithm, and then the value. So we're going to say log base. Remember when we read it, it's log base. That clues us into where that number should go. Log base -5 of -125 equals the exponent. Equals the exponent. Okay. In the next one, log base 0.5 of 8 equals -3. That means base 0.5. Okay, so 0.5 is my base. Whatever my exponent is, that comes from what my log answer was. When I take the logarithm, the answer is -3. That means the exponent is -3. Equals 8. 8's kind of the odd man out. It's not a base, it's not the exponent, it's just the value. In the last one, the base is 2, the exponent is 5. You should start to be able to see that, okay, the base is 2, that goes down below. The exponent is 5. I'm going to put that over here. And then I'm taking the log of 32. The answer to taking the log is an exponent. So when you have an exponent, that's the answer to your log. Okay? Now I know this is tough stuff, but you need to be able to do this. Go back through, look through. If you need to listen to me talk again, listen to me talk again, but I need you to be able to do this. And so what that means is if you have questions, come with them for class tomorrow. Come before school. Write these examples down. Circle any that, Mrs. I don't understand, but you have to put in a little bit of work to make sure you've got it. Okay? Because I want to show you one other thing. I want to show you how this actually works to use as a way to solve. Okay, so let's see if we can make that happen. Okay. Oh, sorry. Before we actually do some mental math, there's some key logarithm rules. That's my bad. If the base and then the value you're taking the log of are equal, then it's going to equal 1. That should make sense. B to the first power, because the answer is the exponent, should equal B. Down here, B to the 0 now as an exponent should equal 1. That should make sense. That's how you being able to transfer between these two is going to make logs easier to understand. Being able to do the transformations or the switching is going to make it easier for you in the long run. Now, when there is no base indicated, nothing is there, it's just empty, use 10. This is called a common log, and this is the log that your calculator does with the log key. So when you don't see a base, think 10 as your base. Okay? So think 10 as your base when there's nothing there. That's called a common log. Okay? Now on to mental math. That was my bad. Sorry about that. So we can use mental math to help us calculate. Log, notice no base, but we can think base 10. Log base 10 of 1,000 is x. How could we get x? Well, we think to ourselves, 10 to the x should equal this 1,000 that we're hearing so much about. What power is 10 raised to give a 1,000? Well, 10 squared is 100, 10 to the third is 1,000. Let's look at the next one. answer is smaller. That probably means that x is going to be a negative exponent. What value should 4 be raised to give 20.25 or 2500ths? Hint, that equals 1/4. This x is -1. Okay? Make the switch and then think to yourself, 25 raised to what power is going to equal 0.04? Now, if you don't know that 0.04 is 1/25, I could see this problem being very difficult for you. If you do know that, hopefully you can see that x again here is -1. That -1 helps us do the reciprocal. The last one. Use mental math here to solve this log. The base is 4. The answer to the logarithm is the exponent to the problem. The answer to the logarithm is the exponent to the problem. The answer is an exponent. The answer is the exponent. So when it's x here, that becomes our exponent for our exponential equation. 4 to the x equals 64. Well, 4 squared is only 16. 4 to the third is 64. You can use this with mental math if you know your exponents. If you don't know your exponents, you're not going to do very well, unfortunately. Or if you don't know how to make this change and say, okay, I have my base, that's right here. That's probably the most important part of doing this logarithm chapter, is being able to change from a logarithmic equation to an exponential equation. You have to be able to make the change to go from here to here and perhaps even back. So make sure you've got that down. If you don't have that down, please come in and ask questions. Thank you, thank you, thank you.